So we have our presentation about errors, and it's in PDF format. If you open it, you will see there's lots of discussion about errors in general, syntax errors, errors that we naturally make because essentially we write our code with some anticipation that it's going to do something. But of course, it's impossible to predict everything to be exactly correct, and therefore errors are very natural. The simplest type of error to fix is a syntax error because compiler simply prevents this program from being compiled. So that's one thing. But another thing is, something that happens at runtime. Sometimes it does happen, sometimes it doesn't happen. So we need to watch out for certain things. And the general approach is to what is the strategy, what is the vision to deal with errors. Let me give you some examples. Perhaps one of the very popular among professional programmers is something called an assert. Assertions are not covered in the book, but they're extremely simple to use, and they're very effective. Let me show you how it works. So once you include this header file in your code, what you can do, and we already have our program, right? So we can say that, for instance, we may have a requirement that this vector of elements that I'm trying to display should not be empty. Okay, so the user, so for instance, I just decided to enforce the fact, although I don't have to, program will probably work okay, but just as an example, that I expect that this vector is not empty. So what I can do after including this C assert header, I can say assert, which means make sure, right, that vect size is greater than 0. So assert looks a little bit like an if statement, right? So what's inside these parentheses is basically a condition. A condition says I want to enforce that size is greater than 0. So let's experiment and see how this assert will behave if the vector actually size becomes 0. So first of all, I will build it and run it. The first time I will just enter some values, and everything works as expected, and then I start the program, right? And instead of entering anything, I will press Ctrl Z, which will close input stream, and this is what happens. I execute my program, and I will just basically copy and paste the resulting output, and I will copy and paste it here so that's easier to see and observe the behavior. Okay, so let's take a look. Right, so I'll resize it so that everything is visible. So it says enter some numbers or press Ctrl Z to exit. And I press Ctrl Z so that I don't enter anything. And look what just happened. Assertion has failed. And it tells me that vector size greater than 0, apparently, this condition right here, was not true. Apparently, the size of my vector was 0. There were no elements in it. And the beauty of this assertion is that it prints file, and this is the whole path to my file, and it also tells me which line number this was happening on. Now also notice that assertion, the work of the assertion is such that it does not, of course, if I'm curious what is this line number, I can press Control C and Control G and say go to line and paste the line number and hit enter, and you see that it takes me right to this line. So I know that this assertion failed, which means that this condition was not true. And behavior of assertion is such that it instantly terminates the program. It doesn't let you to continue to the program. However, it will also in debug mode allow you to stop in debug mode and try to research what is really going on. Right? So this assertion is very simple mechanism, and we call that assertions are proactive debugging tool. Right? Assertions are proactive debugging approach, because you say before anything bad happens, I know that I can check some things, and if these things are not true, then execution of this program is no longer is no longer making any sense. I just want to stop and make sure that I fix the problem, or I need to address it somehow. So assertions are very, very helpful, and if you switch from debug build to release build, the assertions are actually disabled. They can be disabled, so they can be used only during the debugging. So I'm not going to explore furthermore into this area of assertions, because this is not something covered in the book, but you can use assertions very easily. Like I told you, make sure that actually you place assert at the very top of your include list. That's one of the things to remember. And then you can just use these assertions any way you want. Right? Just say assert, provide condition, and you see that it very conveniently prints the name of the file and the line number where this bad thing is happening. What else could I do, right? So let's just say, okay, we just observe the behavior of an assertion. Another thing that I can do is I can force this display elements to, like, this is like possibility, right? Possibility, use assertions. Another possibility, but the problem with assertions is that it terminates the program. It's obviously is very helpful to a programmer, but obviously it will be a really horrible experience for the user. We still have to deal with some errors beyond assertions. So we can do something like this. We can make an if statement and say that if vector size, and repeat the same condition, right? If the vector size is, this time we can say if vector size is greater than 0, then do all of this. So we want to enforce this function to only deal with vectors that are that don't have empty, empty container. So we can add condition like this, and and we can perhaps change the return data type to a Boolean value. And we can say that if vector size is greater than 0, we can return true and say, okay, everything is fine. But then if this condition didn't work, then we can return false. Right? So in this approach, we probably should document this function that it returns true if everything is okay, false otherwise. Right? We probably, since we since we're starting to, utilize certain specific values on function return, we can change the function, and of course we need to document what's happening here so that everybody's pretty clear why are we returning true or false. So true is if everything is okay, and false if we decided that things are not okay. So then if we pursue this strategy, right, what we are forced to do is that we're then forced to check every place where we call display elements. So I will duplicate this and show you that now perhaps what I need to do is I need to say if, right, if display elements worked fine, because now this call display elements now returns true or false, right? True or false is being returned by this function display elements, and if statement can very easily analyze it. Can say then if display elements, we can say everything is okay, right? Just to make sure that it works. Otherwise, we can say display elements this display elements failed. Right? So the disadvantage of using this method, so this method could work, right? This approach could work, that we essentially say that if we're expecting some conditions to be unacceptable, not good in general within our functions, we can pretty much pre-allocate the return value to indicate success or a failure, right? Success or some type of error or unexpected condition. However, many functions already have return value. For instance, if I wanted to have a function such as integer max and take two integers, int x, int y, right? And say if x greater than y, then return x, which is the bigger value, right? Otherwise, return y. So here, this max, which determines the bigger number out of the two, x and y, right? It simply already returns an integer. What if I wanted to also add some error reporting out of this max function and in general do something more sophisticated inside, but at the same time do not change the return type? Naturally, I want to say, something equals max x and y, and instantly get the answer. So this return true or false no longer works. Right? It's just like there's only one return type which is allowed. So what can we do different? What can we do differently here?